Now, next topic, that is potentiometer. Potentiometer, that is the circuit with the help of which one can find the EMF of the cell as well as internal resistance of the cell, and one can compare the EMFs of cells. Okay, as well as potentiometer circuit can be used as potential divider circuit also. Now see the figure here. This red circuit given to you, that is the potentiometer circuit. In potentiometer circuit, between A and C, the long wire is connected. This long wire, that is of the length 200, 300, 400, 500, 600 centimeter. Okay, as per convenience. Okay, it is mounted on the plank. Then between A and C, here a battery with internal resistance R and a resistance box, or we can say the rheostat is connected to control the current in the circuit. So this particular circuit, that is known as potentiometer circuit. Clear up to this one? Now here, first of all, we have to calculate the potential gradient for the potentiometer wire. Potential gradient means what? Potential gradient, that is nothing but the potential difference per unit length of the wire. But to find out the potential difference per unit length of the wire, first of all, we have to calculate the current constituted in the circuit. Now see here, to operate the circuit, the battery with EMF E and internal resistance R is connected. The resistance box R, that is connected in series with it, and a potentiometer wire. All these are connected in series. So we can write the current constituted I, that is equal to E upon R plus resistance of potentiometer wire, that is resistance of AC wire, plus internal resistance of the battery. Now, suppose this current is constituted now. So if current I is flowing through this wire AC, then potential difference between two end terminals A and C of the wire, that we can write. So potential difference across AC, that is current I into resistance of AC. Now substitute the value of current I here. I, that is E upon R plus RAC plus small r into resistance of AC wire. Now here, suppose the resistance per unit length of the wire, that is sigma, then total resistance of this wire, that we can write RAC equal to sigma into LAC, where LAC, that is the total length of the wire. Now this is the potential difference across entire wire. So if we take length of the wire on left hand side, so potential difference across AC divided by length of AC wire, then we can say this left hand side, that is nothing but the potential difference per unit length of the wire, and that is called potential gradient. So we can write that is E sigma upon R plus length of AC wire into sigma plus R, and this is denoted by phi. This is called the potential difference per unit length of the wire, that is potential gradient. Clear to all of you? Now see, when between these two terminal A and C of the wire, total potential difference, that is VAC. So in other words, we can say this wire itself will behave as a source having potential difference VAC between these two terminals. So here, suppose we take one wire from terminal A, which behave as positive terminal because it is connected with positive terminal of the battery. And then after, suppose we take another wire from any point of this potentiometer wire. Now, if here the length of the potentiometer wire used, that is the small L, then across that particular length of the wire, the potential difference obtained, that is 5 into L. So in this way, suppose we fix one terminal of the wire here at A and we keep another terminal as variable, and these two terminal are connected with voltmeter, then for that variable terminal, as you change the position of that terminal on the wire, then different length of the wire will appear in the circuit, and now you will get different potential differences. So we can say potentiometer circuit can be used as potential divider circuit. એટલે કે તમારે અલગ 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 પોટેન્શિયલ્સ જોઈતા હોય તો તમે આ સર્કિટનો યુઝ કરી શકો. Clear to all of you? Now using this potentiometer circuit, we can find the EMF of the cell. See, in normal condition, when you use the voltmeter to find out the voltage between two terminal of the cell, then what happens? Suppose we connect the two terminal of the cell with voltmeter, then the closed loop will be formed. Cell, voltmeter to cell, loop will be formed. So current will be constituted. So current will flow through the cell. If current flows through the cell, then the potential difference between two terminal of the cell, that is not EMF of the cell, but that is the terminal voltage of the cell. Now, if you want to find the EMF of the cell, then you have to make an arrangement in which the current flowing through the cell, that becomes zero. So if current flowing through the cell becomes zero, then whatever is the potential difference obtained across two terminal of the cell itself is the EMF of the cell. Now to find out the EMF of the cell or comparison of EMFs of the cell, we have to connect those cells as shown in the figure. Suppose two cells having EMFs E1 and E2 are connected with a potentiometer circuit as shown in the figure. Positive terminals will be connected with positive terminal of the potentiometer, means terminal A, which is connected with the supply battery, or we can say driver battery, which one is operating the circuit. Then negative terminals are connected with two-way key to terminal 1 and 2. And with this terminal number 3, a galvanometer, and then with galvanometer, a jockey key is connected, which is the variable terminal. So in this way, first of all, we have to prepare the circuit. Clear to all of you? Say, this one is the jockey key, right? Now, here you have to connect the wire to this particular terminal and other end of the wire, that is with galvanometer here. Now, this part of the jockey key that you have to move on the wire, okay, to obtain the null point. Clear to all of you? Now, suppose in this circuit, first we connect terminal number 1 and terminal number 3. So here the cell with EMF E1 that is now connected in the circuit, the cell with E2 EMF that is at present disconnected one. Now, with the help of jockey key, you have to find the null position on the potentiometer wire. So here what happens, see, suppose jockey key is placed at point N1. So length of the potentiometer wire from A to N1, that is suppose L1. Now we already discussed the potential gradient. Potential gradient, that is the potential difference per unit length of the wire. So here L1 length of the potentiometer wire give you the null point. It implies that between these two terminal A and N1, the potential difference that is L1 into phi, that is L1 into phi, and this L1 into phi potential difference that is exactly equal to the potential difference between two terminal of the cell. And when you are getting null point means through the galvanometer, when the current is not flowing means through cell, the current is not flowing. So whatever the potential difference is obtained here between two terminal A and N1, which is L1 into 5, that is exactly equal to EMF of the cell. So we can write here potential difference across A and 1, that is equal to E1, that is equal to L1 into 5. Now disconnect these two terminal 1 and 3 and connect the terminals 2 and 3. So now this second cell with EMF E2 is in the circuit. So for that, again find out the null point. Suppose the null point is obtained at N2 and length of the potentiometer wire which give you the second null point, that is L2. So we can write the potential difference across A and 2, that is equal to E2, that is L2 5. So now take the ratio of these two equations. So we will get E1 upon E2, that is equal to L1 upon L2. Now, if we have the value of potential gradient, then you can calculate the EMF of the cell, and in this way you can compare the EMFs of the cells. Clear to all?